Welcome to Safety 102, Energy Management. I am Saeed Al-Jara, Safety Director with Klume Construction. This module enhances your understanding of electrical safety in construction. While essential to modern work, electricity poses serious hazards that can lead to severe injuries or fatalities if mishandled. This course will equip you to identify and manage electrical risks effectively. Electrical safety starts with awareness and familiarity with OSHA and NFPA standards, which form the foundation for safe practices around electrical systems. This section covers key hazards: electrical shock, arc flash, arc blast, and electrocution. Electrical shock occurs when current passes through the body, causing potential internal burns, heart, or nerve damage. Arc flash releases energy, leading to severe external burns and heat. Arc blast is an explosive expansion of air and material, propelling shrapnel and causing trauma. Electrocution refers to fatal electrical shock. Understanding these hazards is the first step to a safety culture. This course will help you recognize and mitigate these risks with effective safety practices. Always respect electrical boundaries, follow protocols, and never compromise on safety measures. Prevention relies on preparation and vigilance. To effectively manage electrical hazards, it's crucial to know key terms. First, current is the movement of electrical charge through a conductor, measured in amps. Voltage is the electrical force pushing the current through, measured in volts. Resistance is the opposition to current flow, measured in ohms, which affects how easily electricity passes through a material. Conductors allow current to flow easily, for example, metals, while insulators, for example, rubber or wood, resist it, preventing electrical flow. Grounding ensures a safe path for current into the earth, protecting against surges and electrical faults, and preventing shock by ensuring metal parts don't become energized. These fundamental concepts help understand electrical systems and potential hazards. As we progress, we'll explore how these interact and create safety challenges. With these basics, you're better equipped to recognize risks and take necessary precautions. Safety starts with knowledge, and knowing these terms on site is crucial. Before diving into electrical safety, it's vital to outline the course objectives. By the end of Safety 102, Energy Management, you'll gain practical knowledge and tools to safeguard yourself and others. The first objective is understanding regulatory standards from OSHA, NFPA, and other authorities to ensure adherence to best practices in electrical safety in construction. The second is identifying electrical hazards, such as exposed wiring, faulty equipment, and water near electrical systems, which is key to accident prevention. Third, you'll grasp essential concepts like shock, arc flash, arc blast, and electrocution, each requiring specific preventive measures. For example, an arc flash can reach 35,000 degrees Fahrenheit, causing severe burns, while shock, even at low voltages, can be fatal. The final objective is mastering safety controls and practices, including PPE use, lockout tagout, and safe handling of energized equipment. You'll learn to assess risks, select proper safety measures, and apply them effectively. These objectives prepare you for a thorough exploration of electrical safety, enabling you to follow regulations, prevent incidents, protect others, and promote a safer work environment. Adhering to current regulatory standards is vital for workplace electrical safety. Here are the primary standards you should know. OSHA standards, 29 CFR Part 1910 and 1926. These cover safety requirements for general industry and construction, focusing on electrical installations, wiring, and protective equipment. Compliance is mandatory for workplace safety. IEEE. These are the 84 2018 guidelines. These provide methods for arc flash hazard calculations, aiding in risk assessment and appropriate safety measure implementation. NFPA. 70E 2024 Standard for Electrical Safety in the Workplace. The latest edition emphasizes creating an electrically safe work condition policy, prioritizing hazard elimination, and including emergency response plans and job safety plans. NFPA 70 NEC 2023 National Electrical Code. This revised edition addresses evolving electrical systems, including updates on alternative energy, energy management, and new articles on Class 4 fault managed circuits in hazardous commercial settings, staying current with the NEC. NEC ensures compliance with electrical installation standards. Regularly reviewing and integrating these standards into safety protocols is essential for compliance and protecting personnel, helping mitigate risks and foster a safer environment. Electrical hazards vary and pose significant risks if not managed properly. Here, we'll cover common workplace electrical hazards and how to identify them. Overhead power lines are a major danger, often carrying high voltages and typically uninsulated. Contact can be fatal, so always maintain a safe distance and use equipment specifically designed for electrical safety, like nonmetallic or nonconductive ladders. Damaged or faulty tools and equipment are another common risk. Frayed cords, cracked casings, or malfunctioning devices can expose live electrical parts, leading to shocks or arcs. Inspect tools before use and remove damaged equipment from service until repaired. Inadequate wiring and overloaded circuits pose serious risks, leading to overheating, electrical fires, or explosions. Ensure all wiring is up to code and circuit loads are properly managed. Improper grounding is another invisible but dangerous hazard. Proper grounding keeps exposed metal parts at 0 volts to prevent shocks. Without it, workers may be exposed to live currents. Wet conditions heighten the risk of electric shock as water conducts electricity well. Avoid handling electrical devices with wet hands or in damp areas without safety precautions. Specific risks include electrical shock, where current passing through the body can cause severe internal damage or death. Arc flash, producing high temperatures that burn skin and ignite clothing in seconds, potentially throwing workers and causing secondary injuries. Arc blast, creating an explosion with high pressure waves that project shrapnel and can cause hearing damage or trauma. Recognizing signs of hazards like tripped circuit breakers, warm cords, or unusual noises is crucial for safety. Understanding these hazards forms the basis for preventing incidents. Next, we'll cover statistics and case studies that underscore the importance of safe work practices and the consequences of ignoring them. Statistics and case studies are vital for understanding electrical safety's importance and learning from past incidents to prevent future tragedies. From 2011 to 2020, OSHA reported thousands of electrical injuries and hundreds of fatalities, with small employers, 10 or fewer employees, seeing the highest proportion of incidents. This highlights the need for safety training across all company sizes. Between 2003 and 2009, over 20,000 electrical injuries and more than 1,500 fatalities were reported. For each fatal incident, approximately 13 non-fatal injuries occurred, with around 70% of fatalities involving construction, repair, or cleaning work. This emphasizes the risks of working near electrical equipment without proper training or safety adherence. A case study illustrates how routine tasks can become dangerous. A concrete worker picking up debris leaned on a guardrail that had breached a 277-volt lighting circuit, resulting in a shock from their stomach through their arm. Although brief, the incident led to neuropathic pain, sensory loss, and fatigue lasting months. Such cases underscore that electrical shocks can have severe, long-term impacts. Over 98% of deaths from electrical incidents are due to shocks, which cause internal burns and prolonged health effects. Arc flash incidents are equally concerning, with temperatures reaching up to 35,000 degrees, 4 times hotter than the sun's surface. These can cause third-degree burns and fatal injuries up to 10 feet away, with pressure waves leading to secondary injuries. Misconceptions about voltage danger persist. Voltages below 250 volts can be fatal, accounting for about 40% of electrical fatalities. This highlights the need to respect all voltage levels. Understanding these cases and statistics reinforces the necessity of strict safety adherence, proactive measures, and a culture of hazard awareness. In the next section, we'll cover specific workplace hazards and safety management strategies. Electrical work environments pose unique hazards requiring vigilance and strategic safety measures. This section will address common workplace risks and how to mitigate them to ensure worker and equipment safety. Working near equipment with exposed components, like open panel boxes or battery terminals, poses significant risks. Accidental contact can lead to electric shock or arc flash. Always inspect equipment and surroundings thoroughly before starting tasks. Dropping tools or materials into equipment openings can cause arc flash, damage, or equipment failure. Handle tools carefully and be aware of their position relative to electrical components. Paint overspray, water intrusion, and dust can compromise electrical equipment and increase arc flash or failure risks. Dust can cause insulation breakdown, short circuits, and overheating. Implementing foreign material exclusion (FME) protocols, such as maintaining clean environments and using containment barriers, helps mitigate these risks. Testing, commissioning, and energizing systems pose additional hazards, often exposing workers to energized parts. Only qualified personnel should perform these tasks to safely handle energy sources and potential backfeeds. Signs of potential hazards include tripped circuit breakers, warm tools or wiring, blown fuses, and frequently shutting off GFCIs. Recognizing these early can prevent incidents. Always heed warning labels, barriers, and restricted area notices. By staying vigilant and applying preventive measures, risks can be mitigated to ensure a safer work environment. Next, we will explore electrical protective devices that play a crucial role in safety. Electrical protective devices are vital for maintaining a safe work environment by shutting off electricity during overloads or ground faults. Key devices include fuses, circuit breakers, and ground fault circuit interrupters, GFCIs. Fuses contain a metal wire that melts when excess current flows, cutting off the circuit to prevent system damage. They must be replaced once blown. Circuit breakers, in contrast, can be reset after tripping and protect against overloads and short circuits, preventing electrical fires and damage. GFCIs protect against electric shock by detecting current imbalances. If an imbalance occurs, indicating a ground fault, they immediately shut off the circuit. GFCIs are essential in areas where water and electricity may meet, such as kitchens, bathrooms, and outdoor sites. These devices work by sensing conditions that could lead to hazards and interrupting the circuit. For example, circuit breakers trip during surges, while GFCIs respond to leakage currents. Regular inspection and testing are crucial to ensure they function properly, and workers should recognize signs of malfunction like frequently tripping circuits or non-resetting GFCIs. Understanding and properly using these devices is essential for safety, as they help detect and prevent potential hazards before escalation. Next, we will cover safe practices for avoiding exposure to energized parts and handling electrical equipment. Avoiding exposure to energized parts is crucial for preventing shock, burns, or fatal injuries. This section outlines best practices for working safely around energized parts. Start by conducting a thorough visual inspection before any task. Check for exposed wiring, open panels, and damaged insulation, and ensure covers and guards are securely in place. Address any issues before proceeding. Maintain proper work boundaries and never reach into open panels or boxes without training and PPE. Barriers and guards prevent accidental contact and should be respected. Only qualified personnel should access energized areas. De-energize equipment before work using lockout, TIG-out, LOTO procedures, and verify the absence of voltage with reliable testers, following the live-dead-live method. First, test the tester on a known live source, then test the equipment to confirm it is de-energized, and finally retest the tester on the known live source. Stay vigilant around de-energized equipment, as incorrect isolation or residual energy can keep components live. Ensure grounding and insulation checks are part of your process. Battery terminals can pose risks due to high current potential. Avoid placing metal tools near them to prevent accidental contact. Use tools rated for the system's voltage and inspect them regularly. Never work alone in high-risk areas. Having a colleague present ensures immediate help if needed. These safety measures, from inspections to PPE and maintaining safe distances, embed safety into daily work practices and protect everyone involved. Next, we'll discuss guarding live components and meeting OSHA accident prevention requirements. Guarding live components is vital for preventing accidental contact and potential injuries or fatalities. This section covers methods and OSHA requirements for guarding energized parts. Electrical equipment operating at 50 volts or more must be protected against accidental contact. Approved cabinets or enclosures are a primary method, physically separating energized components from personnel and only accessible to qualified workers. Location-based guarding places equipment in restricted areas, keeping unqualified individuals away. Permanent barriers or partitions can be used to maintain safe distances. Components positioned 8 feet or more above the floor are considered safely guarded by elevation but should still be marked and monitored. Warning signs at entrances to areas with live components reinforce safety by alerting workers to energized parts and reminding them to exercise caution. Compliance with OSHA regulations for guarding live components is crucial. OSHA mandates that all live parts must be enclosed or guarded in areas where they could be exposed to physical damage. Non-compliance can lead to serious safety violations and increased risk of electrical incidents. Guarding not only protects individuals from direct contact, but also prevents foreign objects from contacting energized parts, reducing risks like short circuits or arc flash. Maintaining enclosures, barriers, and warning signs is essential. Regular inspections ensure guards remain intact and undamaged, with prompt repairs or replacements as needed. Guarding live components is a proactive measure that complements other safety practices, creating a comprehensive approach to minimizing electrical hazards and fostering a safer workplace. Next, we'll cover grounding and power line safety, focusing on grounding hazards and safe practices around overhead power lines. Grounding and power line safety are essential for protecting workers and equipment. Grounding provides a safe path for electrical current to the earth, reducing risks of shock and fire. However, faulty or interrupted grounding increases shock risk. For example, improperly grounded tools can become energized, posing serious hazards. Common grounding issues include missing or damaged ground prongs on extension cords, improperly connected grounding wires, faulty outlet grounding. Inspect cords, plugs, and outlets for damage and ensure proper grounding. Use GFCIs in high-risk areas for added safety. Overhead power line safety is critical, as these lines carry high, often uninsulated, voltages. Electricity can arc over short distances, making even proximity dangerous. Key safety tips. Maintain at least 10 feet distance for lines up to 50,000 volts, more for higher voltages. Use non-conductive tools like fiberglass ladders. Avoid conductive objects near power lines. Ensure proper training, PPE, and use of a spotter when working near power lines. If work near power lines is necessary, coordinate with the utility company to de-energize and ground the lines or use insulating barriers. Grounding and power line safety protocols are life-saving practices. Properly managing these hazards can greatly reduce the risk of shock, burns, and fatalities. Next, we'll review OSHA violations and safety practices with real examples and prevention strategies. Understanding common OSHA violations related to electrical safety is key to preventing incidents and ensuring compliance. Here, we cover frequent violations and best practices to avoid them. One common violation is an interrupted grounding path. OSHA requires circuits and equipment to have a permanent, continuous path to ground. An extension cord missing a ground prong is a typical example, posing serious risks if energized. Another violation involves unguarded live parts. OSHA mandates that live parts must be enclosed or guarded to prevent contact. Exposed wires due to damaged conduit are examples of non-compliance. Keeping conduits and electrical housings well maintained is essential. OSHA also focuses on the safety of cabinets, junction boxes, and fittings. Approved covers must be used and unused openings sealed to prevent debris entry. Violations include missing knockouts or exposed live parts due to damaged covers. Improper use of flexible cords is another concern. Cords should not replace fixed wiring or be run through walls, ceilings, or windows. Damaged cords can lead to shocks, burns, and fires. Use cords appropriately and inspect them regularly. Dust and debris around electrical equipment are also issues. They can compromise system integrity and cause short circuits. Implementing foreign material exclusion, FME practices, and maintaining clean work areas are crucial. Best practices to prevent OSHA violations. Conduct regular safety audits. Train employees to recognize electrical hazards. Repair or replace damaged equipment promptly. Use proper signage and barriers around live electrical parts. By understanding these violations and employing preventive practices, workplaces can enhance safety and reduce risks. Next, we'll discuss dust and debris management for protecting equipment and maintaining a safe environment. Dust and debris can pose significant risks to electrical equipment and safety. Managing dust is essential for protecting electrical systems and maintaining a safe work environment. Dust accumulation on electrical components can trap heat, causing overheating and increasing the risk of failure or fire. Conductive dust, such as metal shavings, can lead to short circuits and arcing. Maintaining a clean work environment is key. Regularly clean work areas and control dust-producing activities. Use containment barriers and vacuum attachments on tools when working with dust-generating materials like concrete or drywall. Plan work involving dust or debris with appropriate management measures to shield electrical equipment from contamination. Implement foreign material exclusion (FME) protocols, covering open equipment and using dust caps to keep contaminants out. Training workers to protect equipment during activities like grinding, drilling, sanding, and metal cutting is essential. Use vacuum systems for debris removal and air filters in enclosed spaces. Avoid using compressed air for cleaning accumulated dust. Use specialized vacuum attachments instead. Effective dust management protects electrical equipment and contributes to a safer workplace, preventing conditions that could lead to electrical incidents. Next, we'll discuss equipment handling and lifting safety, focusing on managing equipment safely and avoiding electrical hazards during material handling. Proper equipment handling and lifting are vital for electrical safety to prevent accidents and injuries. This section covers best practices for safely using lifts around electrical systems. When using scissor lifts, forklifts, or similar equipment near electrical systems, ensure only trained, authorized personnel operate lifts near electrical equipment. Inspect the area for hazards, such as overhead wires or confined spaces, before lift operations. Use a spotter in areas with limited visibility or close proximity to electrical components to guide operators and monitor for risks. Secure all materials on lift platforms to prevent items from falling and potentially damaging electrical components or causing arc flashes. Ensure platforms are clear of loose items before raising or moving. Avoid accidental contact by positioning materials like pipes or beams safely. Workers should not lean or reach outside the lift platform to prevent contact with electrical sources. Forklifts present additional risks. Secure loads to prevent shifting that could lead to impacts with electrical installations. When lifts operate near overhead bus ducts or other electrical installations, use non-conductive guards or barriers and maintain safe distances. Proper training and planning are essential to avoid misjudged distances and unexpected movements. Equipment handling and lifting near electrical systems require attention, inspections, and strict safety adherence to protect workers and preserve equipment integrity. Next, we'll discuss arc flash and blast hazards, their causes, warning labels, and risk assessment methods. Arc flash and blast hazards are among the most severe electrical risks. Understanding their causes and prevention measures is crucial for safety. An arc flash occurs when electrical current travels through the air between conductors or to the ground, releasing immense energy as light, heat, and pressure, with temperatures reaching up to 35,000 degrees Fahrenheit. This heat can cause severe burns, ignite clothing, and melt metals. An arc blast follows the flash, creating an explosion of gases and materials. High-pressure waves from the blast can propel shrapnel at high speeds and produce noise levels exceeding 160 decibels. The combination of heat, pressure, and debris makes these incidents potentially lethal. Common causes of arc flash and blast include accidental contact with energized parts due to tools or human error, insulation failure from moisture or environmental factors, voltage transients or surges leading to system breakdowns, lack of proper maintenance or ignoring recommended inspection schedules. To minimize these risks, Regular preventive maintenance is key. NFPA 70E guidelines stress the importance of checking for loose connections, cleaning equipment, and following maintenance schedules. Arc flash hazard warning labels are essential for preventing incidents. Per NFPA 70E 130.5 electrical equipment needing maintenance while energized must have labels with critical safety information, including nominal system voltage, arc flash boundary, distance for potential second-degree burn, incident energy or minimum PPE arc rating required, working distance and site-specific PPE requirements. Understanding and following these labels ensures workers are prepared, using the correct PPE and safety protocols for the task. Conducting an arc flash risk assessment is crucial before working with energized equipment. This assessment involves evaluating exposure potential, calculating incident energy levels, and setting boundaries, such as the arc flash boundary, where the incident energy is 1.2 cal centimeters post energy to limit the risk of second-degree burns. Based on these assessments, workers must wear PPE that matches the hazard category, including arc-rated clothing, face shields, gloves, and insulating gear designed for the specific energy levels. Although arc flash and blast hazards are serious, adherence to preventive measures, proper labeling, and thorough risk assessments significantly reduce the risk. Always prioritize safety with the right knowledge, tools, and PPE. Next, we'll detail the types of PPE required for different hazard categories and the importance of proper usage and maintenance. Personal protective equipment, PPE, is a crucial defense when working around electrical systems. Choosing and using the right PPE can mean the difference between a minor incident and a serious injury or fatality. The type of PPE needed depends on the task's risk level, categorized by potential incident energy levels. Higher energy levels require more protective PPE. PPE is tailored to the level of hazard involved. Category 1, arc-rated long-sleeve shirts and pants. Minimum 4 cal, CM2, safety glasses or goggles, and ear protection. Category 2, arc-rated clothing, minimum 8 cal, CM2, and arc-rated face shield with a balaclava, and heavy-duty or rubber insulating gloves with leather protectors. Category 4, full arc flash suits, minimum 40 cal, CM2, arc flash suit hoods, rubber insulating gloves with protectors, hearing protection, and leather footwear. Proper PPE use includes ensuring correct fit, checking for wear or damage, and replacing damaged items immediately. Maintenance involves following manufacturer cleaning guidelines, avoiding fabric softeners, bleach, and proper storage in clean, dry conditions away from sunlight and chemicals. Training is essential for workers to understand how to inspect and use PPE properly, recognize issues, and select appropriate gear for specific tasks. ASTM and ANSI provide PPE specifications, and OSHA requires employers to provide and enforce PPE usage where electrical hazards are present. Next, we'll cover voltage-rated tools and their standards to enhance electrical safety. Voltage-rated tools are essential for safe electrical work, protecting users from shock and arcing. These tools are insulated to prevent current flow and must be tested to ensure they don't conduct electricity up to their rated voltage, which is typically marked on the handle. Examples include insulated screwdrivers and pliers for electrical panels, insulated wrenches and sockets for adjusting components, insulated voltage testers for checking current presence. Insured tools meet safety standards, for example, ASTM, IEC, and are rated for the appropriate voltage with a safety margin for unexpected surges. Inspect tools for damage, such as cracks or compromised insulation, before use. Damaged tools should be removed from service. Regular testing and certification help maintain tool integrity. High-quality tools use non-conductive materials to ensure safety. Proper storage in dry, clean areas protects insulation and tool condition. Voltage-rated tools add a critical layer of safety when working near energized systems. Using and maintaining them correctly reduces electrical accident risks and promotes a safer work environment. Next, we'll discuss lockout-tagout, LOTO, procedures and safety measures for preventing accidental equipment startup. Lockout-tagout, LOTO. Procedures are crucial for protecting workers from accidental equipment startup or hazardous energy release during maintenance. OSHA Standard 29 CFR 1910.147 outlines these requirements. Essential LOTO steps. 1. Notify affected personnel about the equipment shutdown. 2. Shut down equipment and ensure it is fully stopped. 3. Isolate all connected energy sources, e.g., electrical, hydraulic. 4. Apply locks and tags to isolation devices marked with reason, applier, and date. Each worker should use their own lock. 5. Release any residual energy, e.g., drain capacitors. 6. Verify isolation using a tester with the live dead live method. 7. Perform maintenance while maintaining clear communication. 8. Remove LOTO devices after work is complete. Each worker must remove their own lock and tag. Common causes of LOTO-related incidents, known as the Fatal 5, include failure to stop equipment, failure to disconnect power, failure to release residual energy, accidental reactivation, inadequate training. Employers must train and retrain employees on LOTO procedures and ensure compliance. Proper LOTO adherence prevents injuries and fatalities, creating a safer work environment. Next, we'll discuss emergency response and training, including contact release and electrical first aid practices. Being prepared for electrical emergencies is critical for safety. Proper response, first aid, and timely assistance can save lives and reduce injury severity. This section covers essential emergency response elements, including contact release procedures and first aid training. Quick escalation of electrical emergencies means improper responses can worsen the situation. Well-trained personnel are essential for effective handling. Training for personnel. Qualified personnel should be trained to recognize electrical hazards, respond to incidents, and perform first aid or resuscitation if needed. Unqualified personnel should be trained to identify emergencies, alert responders, and understand basic principles to avoid exposure during incidents. Contact release procedures. Acting quickly and safely is crucial if someone is in contact with a live electrical source. Steps to follow. Do not touch the victim directly to avoid becoming part of the circuit. Stop the electrical current by turning off the main switch or circuit breaker if possible. Use a non-conductive item, e.g., wooden stick or plastic pole, to separate the victim from the source while maintaining distance. Call emergency services immediately for medical assistance. After separation, assess the victim's condition and provide first aid as needed. If they are unresponsive, administer CPR until help arrives. Employees should be trained in basic first aid, CPR, and AED use. All employees should undergo emergency response training per NFPA 70E 2021, including contact release, first aid, and resuscitation. This training helps workers assist safely without putting themselves at risk. Reporting procedures. Proper incident reporting is essential after an electrical incident. Document the event, identify causes, and implement corrective actions to prevent recurrence. Reporting helps refine safety protocols and trains employees with real-life scenarios. Regular emergency response drills ensure employees remain prepared. These drills should simulate electrical incidents and evaluate response effectiveness. Training should be refreshed regularly and updated when new procedures or equipment are introduced. Effective emergency response training, quick thinking, and adherence to procedures significantly reduce the impact of incidents. Next, we'll cover training, retraining, and best practices to maintain high electrical safety standards through continuous education. Ongoing training and education are the backbone of a strong electrical safety program. Consistent training ensures employees stay aware of current protocols, understand risks, and respond effectively. Training should match the roles of employees. Qualified personnel need detailed education on electrical systems and safe practices, while unqualified personnel should learn to recognize and avoid risks. Retraining is needed when new equipment or procedures are introduced, safety standards are updated, inspections show non-compliance, employees must use unfamiliar work practices. Per NFPA 70E 2021, retraining intervals should not exceed 3 years, but regular refresher courses and safety meetings are advised. Employers must ensure training is documented, comprehension is verified, and materials are updated as needed. Best practices for enhancing electrical safety. Conduct regular audits and inspections to identify hazards. Foster a safety focused culture that encourages hazard reporting. Update training materials with the latest safety standards. Reinforce safety boundaries and access controls. Promote proper PPE use and maintenance. Include hands on practice and emergency drills to build confidence and readiness. Implementing these practices reduces risks and creates a workplace that values safety. Safety evolves with new technology and standards, so staying proactive and informed is essential. With continuous training and these practices, employees can uphold high safety standards and contribute to a safe, productive work environment. In the final section, we'll summarize the key takeaways and emphasize ongoing commitment to electrical safety. Congratulations on completing Safety 102, Energy Management. This course covered essential electrical safety practices in construction, emphasizing awareness, regulation adherence, and proactive measures. Key takeaways: comply with OSHA, NFPA 70E, and NEC standards for safe electrical practices. Understand hazards like shock, arc flash, and arc blast to apply effective safety measures, including PPE, grounding, and voltage rated tools. Ensure equipment is protected by functional circuit breakers, fuses, and GFCIs to prevent incidents. Follow equipment handling guidelines, avoid exposure to energized parts, and adhere to lockout, tagout, loadout procedures. Know emergency response and first aid, including contact release and CPR, to act quickly and save lives. Commit to continuous training and best practices to stay prepared for new challenges and reinforce a safety focused culture. After completing the course, print or take a screenshot of the completion certificate and bring it to your next Clune project. Present the screenshot or printed certificate to the project superintendent to receive a sticker. Place the sticker on your hard hat. It is valid for the specified calendar year, meaning this step only needs to be completed once per year for each employee. Electrical safety is a shared responsibility. Every precaution you take helps protect not only yourself but also your colleagues. Stay informed, proactive, and respect the power of electricity. Thank you for your commitment to safety. Apply these principles to create a safer, compliant, and productive work environment. Stay safe and prioritize safety always.